The presentation on our paper ViralBERT, which is a user-focused BERT-based approach to virality prediction. In our paper, we look at the virality on Twitter, in which tweets get interaction from a relatively large number of users compared to other posts. It is important to predict virality as viral posts have large effects on social, economic, and political outcomes, such as the spread of fake news during the pandemic. In our study, we use deep learning methods and NLP techniques on user and content-based features to predict the virality of tweets. The data for the study were collected through the Twitter API, which use context annotations, which are used to extract tweets that fall under these topics. These topics are chosen as they are generally popular over time, and using context annotations allows us to filter a large amount of the spam on Twitter. Retweets are used as a label as it's indicative of tweet propagation to other users. Virality classes are derived from these tweet numbers. A key limitation to the study is that the dataset collected is imbalanced towards lower virality classes. Our proposed model uses BERT in two ways. The first way is a module for sentiment analysis using Roberta on tweet text. Sentiment has been proven in other papers to elicit emotional response and interaction from users. The second is by concatenating the numerical features listed here with the tweet text separated by the SEP token and feeding this into the BERT model pre-trained for tweets. The formal representation for this input is shown here. The outputs of these BERT models are fed into classification layers. We use a fully connected flat MLP structure with tan H activation, followed by a dropout of 0.1 before final linear prediction layer, which outputs the probability that belonging to a virality class after being fed into a softmax function. This table shows the result of our proposed model compared to the baselines in our study. MLP numbers and numerical features in a multi-layer perceptron, and ViralBERT text is using BERT on tweet text only. As you can see, ViralBERT achieves higher evaluation metrics compared to the baselines. Conduct a study to measure the importance of each feature to ViralBERT by removing a single feature from the input and measuring performance. Removing either sentiment or follow counts reduces performance significantly, and removing mentions counts and following counts have a less significant but still noticeable effect. Surprisingly, removing hashtag counts slightly improves model performance, which means that this count is unrepresentative of virality, and adding this feature makes BERT learn worse representations for prediction. This study can be extended several ways. Firstly, more complex approaches such as a hybrid multitask architecture could be used to help overcome data imbalance. Furthermore, a more balanced dataset could be collected, and the data collection methods could be improved by getting viralities from less popular users. A larger dataset could also help with training the model. There could be studies on using this model on other social media to test adaptability. Work should be done to incorporate more languages to the model so virality can be predicted in different localities. A module for media such as images, GIFs, and videos could also be introduced instead of focusing purely on tweet text. Thank you for listening to the presentation.